name is Jonas Nora. I'm a reservoir geophysicist, mainly working in oil and gas industry. And I'd like to present my mini project. It's called Neural Network for Enhanced Oil Recovery. So for those who haven't known about EOR, I will explain it a bit about what is EOR and then why neural network I believe this is can be useful for the EOR. So EOR is basically a technique to increase the recovery of oil and produce the residual oil in the reservoir. Well, when an oil field near its depletion or near its end of the life, the productivity decreases because the reservoir pressure decreases. So at this moment, we can increase the productivity by using enhanced oil recovery. Actually, there are lots of methods in EOR, but here I show 9 of them. This is actually, I got these methods from Tabor et al. In 1997, the year when I was born. He's working in New Mexico oil project. So these are 9 methods: the nitrogen injection, CO2, hydrocarbon immiscible gas, ASP, polymer, combustion, steam, and mining. And basically how we choose what method of EOR is suitable for our field, we have to look at the properties inside the reservoir. Actually, this is the physical properties. Gravity, viscosity, it's the basic properties of the fluid. This blue color represents the fluid properties, and this yellow color represents the rock properties. So the question is, why neural network is useful for this? Why it's really important for us in the oil and gas industry? Well, there are lots of data that can be optimized, and there are lots of oil fields out there which have applied this EOR project. So I think it will be useful to use this data to train the data so that this neural network can give us a better recommendation for which EOR methods is best for our field. So here I present 7 steps. The first one, I create a synthetic data. Actually, I did it using NumPy random, and in a random fashion, I generated as much as 245 observations, and each observations consists of these properties. So this little star that I show it, this one is the properties that I use for the neural network model. And then based on these properties, I also make labels. The labels is this EOR methods. Then I associate these labels to the synthetic data. And then I also generated 50 data sets to represent the testing data. And then after that, I built a neural network, the architecture that I will present after this. And then I encode the labels. Why I have to encode the labels? Well, because it's a categorical, so I have to encode the string into a numerical values. So at the end of the training, I decode it back into the labels. And I train the model, and then I test the data, predict the data, and then after that, I obtain the predicted result. Basically, this is the architecture. Wait a second. Okay, so actually, my project is in my GitHub. So if everyone interested to see, you can visit this link. Okay, so this is the architecture. So this one is I have 6 input neurons and 7 output neurons. The 6 input neurons is the features, and the output neurons is the EOR methods that will be chosen. And then I use the 100 hidden neurons in the first layer, and then 50 in the second layer. For the activation function, I use a ReLU for the hidden neurons, and then softmax for the output neurons. For the optimizer, I use Adams, loss function, categorical cross entropy. Why? Because I apply into a categorical features, and then through the 100 epochs. And this is the result. of my experiment. At the left here, you can see the pair plot of the properties from the synthetic datasets that I generated. This one corresponds to each properties: density, viscosity, oil separation, etc. And after training the model, this one is the result of the accuracy and the loss history. For this neural network, I achieved 0.7492, and after this experiment, I obtained this result. Basically, it's I can say that a human can do this as well. An engineer can do this in the field, but I'm just curious how neural network can perform this task as better as human. So here you can see, based on these numerical values, the neural network will try to predict which EOR methods is suitable for the field itself. So this one, for example, observation number 0, the EOR method is nitrogen, and then in the for the fifth field, CO2, and then etc. So yeah, basically it's my experiment. I hope I can improve it more later. So if you have any suggestions or any feedbacks or any questions that you want to ask from me, I'll be open for that. Okay, so thank you for attending, guys.
Okay, thank you very much. Thank you very much,
My pleasure.
Johannes. Maybe the questions for this, we're a little bit over time, should be shifted to the discussion group. I think that's very good.